Ever wondered what's really going on inside your code? You know, not just the lines you wrote, but what the machine is actually doing, instruction by painful instruction. Well, today, we're grabbing a flashlight and a map to do just that, using two incredibly powerful tools. Okay, let's dive in.
Oh, we've all been there. You write the code, you compile it, you run it, and bam, segmentation fault. Your program just completely falls over. It's so frustrating, right? You're just left staring at a blinking cursor with absolutely no idea what just happened inside that black box you created.
But what if you didn't have to guess? What if you could become a kind of software detective? Meticulously replay the final moments of your program's life to find the exact line, the exact variable, the exact reason it crashed. Well, that's the mindset we're getting into today. We're officially moving from guesswork to investigation. So here's our game plan. First, we'll crack open that black box with the legendary GNU debugger, or GDB. Then we'll build out our detective's toolkit with all the essential commands. After that, we're going to seriously level up with an amazing extension called PEDA to unlock its security superpowers. And finally, we'll get you ready to start your own investigation.
Every program is basically a black box. We put inputs in, we get outputs out. But that whole complex dance of logic and memory happening in between, it can feel like a total mystery, especially when things go wrong. So our first mission is to find a way to pry that box open.
And this is our crowbar, GDB, the GNU debugger. It is the original, the classic, the absolute essential tool for this job. Think of it like giving yourself X-ray vision for your code. It lets you freeze time, peer inside memory, and watch your program run one single step at a time. Or it lets you do a perfect digital autopsy right after a crash. Okay, before we start sleuthing, we need to do a tiny bit of prep work. First, a quick version check is super important, because the PEDA extension we'll be using later works best with GDB version 13.1 or older. But honestly, the most important step is this last one. When you compile your code, you have got to add the -G flag. This flag tells the compiler to pack in a bunch of extra info, these debug symbols, which are basically a map that lets GDB connect the low-level machine code back to your original source code. Seriously, without it, GDB is flying blind.
All right, with our setup all done, it's time to put on the detective hat. GDB isn't just a program, it's our partner in crime solving. It gives us the power to control time and space inside our application's little universe. And trust me, that is an incredible feeling.
Every detective needs to control the scene of the crime, right? Well, with GDB, run starts the action. Kill stops it dead in its tracks. But the real power move here is break. Think of the break command like setting up a stakeout. You tell GDB, hey, when the code gets to this specific function, I want you to freeze everything. I need to look around. Then continue, or just C for short, tells the program to run full speed until it hits your next stakeout point.
So, your program's frozen at a breakpoint. How do you move forward? You've got two main choices, and this is a really crucial decision. Step, or just S, will dive into the next function call. You use this when that function is your prime suspect, and you need to see exactly what it's up to. Next, or N, is for when you trust that function. It just executes it in the background and moves you to the very next line in your current file. So think of it this way. Step is for a deep interrogation. Next is for when your witness has a rock-solid alibi. Okay, so we can control the flow of our program like a master puppeteer. But a detective is only as good as the clues they can find, right? So now, let's fill our toolkit with the commands we need to examine all the evidence that gets left behind in memory.
This is how we start gathering those clues. Disassemble peels back the curtain and shows you the raw assembly instructions the CPU is actually running. Print is basically your magnifying glass. You can use it on a variable name to see what's inside, or even point it directly at a CPU register like $EBP to see what value it's holding. And if the value just looks like a bunch of random numbers, try P/X to print it in hexadecimal, which is the native language of memory.
But sometimes, looking at a single variable just isn't enough. You need to see the whole crime scene, a whole chunk of memory. For that, we use the examine command, or just X. Now, I know this command on the screen looks like some kind of cryptic password, but it is one of the most powerful and useful tools in your entire kit. It's telling GDB to show us the very top of the program stack.
Let's decode this thing together, because once you get it, you'll use it all the time. Think of it like a recipe. The first X is the command, examine some memory. The slash after it basically starts the recipe's ingredients. The 40 is how many. I want to see 40 items. The W is the size of each item, a word which is usually 4 bytes. The second X is the format. Show them to me in hexadecimal. And finally, $SESP is where to start, the stack pointer. So put it all together, and X/40WX $SESP just means show me 44-byte words in hex starting from the top of the stack. See? Not so scary when you break it down.
All right, you've now got the GDB fundamentals down. You can hunt down bugs, you can understand crashes, but what if your goal changes? What if you want to go from being a coder who fixes programs to a security researcher who understands how to break them? For that, we need to level up.
And that's where PEDA comes in. It stands for Python Exploit Development Assistance. It's a totally free extension for GDB that takes our detective toolkit and just bolts on a whole set of forensic tools designed specifically for security research and, well, as the name says, exploit development, which is the art of turning a simple software bug into a full-blown security breach.
Now here's the absolute best part about this. PEDA doesn't replace GDP, it just makes it better. You are not throwing away anything we just learned. Every single one of those commands, run, break, step, print, X, they all still work perfectly. You're not learning a whole new tool, you're just adding superpowers to the one you already know.
So what exactly are these superpowers? Well, PEDA is all about saving you time and mental energy. It automates a lot of the common, really tedious security tasks and presents critical information in a much clearer, more intuitive way. That lets you focus on the real puzzle.
The very first thing you'll notice is the screen. The moment you hit a breakpoint, PEDA completely transforms your GDB session. Instead of a blank prompt, it gives you this awesome multi-panel display showing you everything you'd want to see, the code you're about to run, the current state of all the CPU registers, and a little peek at the top of the stack. It's like it automatically runs your 3 favorite commands for you every single time the program stops. It is a massive quality of life upgrade.
Okay, now for one of PEDA's signature moves, finding a buffer overflow. This is a classic vulnerability where a program tries to stuff way too much data into a memory buffer. That data spills out and can overwrite critical things, causing a crash, or, worse. PEDA turns finding these into a simple 3-step process. 1, you use pattern create to make a long, unique string. 2, you run the program and feed it that string until it crashes. 3, when it crashes, some part of your unique pattern has overwritten a critical memory address. You just type pattern search, and PEDA tells you the exact number of bytes it took to cause that crash. Knowing that precise number is the absolute first step in crafting an exploit. It's so powerful.
And the power-ups don't stop there. If you need to test an exploit, PEDA can generate common shellcode for you right inside the debugger. That's the little piece of code that an exploit uses as its payload. Wondering what defenses you're up against? A single command can check for security features like ASLR, which shuffles memory locations around to make exploits harder. It's a huge time saver.
Okay, wow. We have covered a ton of ground here. From the fundamentals of just controlling a program to the specialized tools of security analysis. Now let's just bring it all together and see what this really means for you. So, the crucial point is this. Learning GDB and PEDA is so much more than just learning a list of commands. It's a fundamental shift in how you see software. You've gone from being a programmer who just writes code to a detective who can interrogate it, understand its deepest secrets, and uncover its hidden flaws.
And that leaves us with one final thought. You now have the keys to unlock pretty much any black box you come across. You can pause time, inspect memory, and trace the logic of some of the most complex systems on Earth. The only question left is, what are you going to choose to discover first?